Here we are for Algebra 2, Lesson 7-4 on two-way tables. This is Mrs. Shiwi, and we're going to get started with what is a two-way table. First of all, it's just a way of organizing data. You've seen a bunch of these, I'm sure, in your past, but basically, if we asked 20 children and adults whether they like broccoli, not sure that's going to be accurately represented here, but this is the results they got. The two-way table shows how the data is broken down between the two categories. So according to this, 3 children said yes, 8 said no, 7 adults said yes. I'm not sure that that's accurate. Anyway, what we can do with the two-way table is find some different probabilities, or we are going to call them frequencies also. So the joint relative frequencies are the values taken from each space inside the two-way table divided by the total number of values. So first of all, we know there are 20 children. So we can just take each of these values and divide them by 20. So if you take 3 divided by 20, and just turn them into decimals, this would be 0.15. If we take 8 divided by 20, that's 0.40. 7 divided by 20 is 0.35, and 2 divided by 20 is 0.1 or 0.10. If you look at all these numbers, that will add up to 100%. So we have 100% of the population represented. These are called joint relative frequencies, each of the numbers in this box. I'm going to circle that in pink so that this is correlated here. So the next one is marginal relative frequencies. And they're found by just adding up the joint ones. So if we just add these two numbers up in a downward direction, we get 0.5. And we add these two up, we get 0.5. We can also add horizontally, and we get 0.55 and 0.45. And you'll notice if you add down, you get 1.0. And if you add across, you get 1.0. So these blue numbers are the marginal relative frequencies, and you can use these to answer questions about probability. Let's take a look at another example of a little bit larger table that we can figure this out. So it wants us to basically put together the whole table of what we just did. So we could add up all these numbers. Sometimes they tell you. So this table shows a poll of 80 randomly selected high school students who were asked if they prefer math or English. And so we can find all of the joint relative frequencies by taking each of these numbers divided by 80. So here we go. 10 divided by 80 is 0.125. 12 divided by 80 goes here. I'm just going to go across. 11 divided by 80, and you can round if you have to, but we're going to go out 4 spots there. And then 8 divided by 80 is 0.1 or 0.10. You can, however many decimals. All right, let's go ahead and do the English. Starting with 9th grade, divide that, we get 0.15, 0.1375, 0.1, and 0.1. So those are our joint relative frequencies. And now we're going to do our marginal relative frequencies, which means we're just going to add straight down on all of these columns. And here, 0.2375 and 0.2. And you can add across here, 2, 4, 6, 8, 9. It should add up, and this is kind of how you check your math, to exactly 1. And then we can also go across here. So if we add these across, we get 0.5125 and 0.4875. So there's a lot of things you can answer. We'll answer some questions in a little while, but for now, we're just kind of setting up the data. We could ask how many, what's the percent of people taking a math versus taking an English, all kinds of things. Let's go ahead. All right, this is one more. I want you to go ahead and solve that and pause the video and come back and see if you get these answers. And I'm going to fill it in. So if you want to fast forward to my answer, you can. Pause now. All right, so if you didn't catch that, the first thing you might need to do is add all these up. so that you can then divide them to get these answers. And that is how you fill in a relative and joint and marginal frequency table. All right, this one has a table and then some probability questions. So the first thing we want to do before we start trying to answer those questions is fill in the table. So we have 100 animals total. And so we're going to divide each of those and fill in your table. Again, you're welcome to pause the video or just go ahead and fill it in with me as I go. And we add those up, we get the bottom row, and then we can add horizontally, vertically, either way we should get a total of 1. Now, how in the world do we use this to answer frequency questions? First of all, just a little reminder, this means find the probability of selecting a cat given that you've got a dog, right? So if you already have a dog, what's the probability of selecting a cat? So we start out with the probability of cat, which is 0.15, and we divide that by the probability that you have a dog, which is 0.39. So out of the ones that are dogs, which the total there is 0.39, how many of them are cats, which is 0.15? So we divide these two fractions here. And if you divide those, you get 0.38. And we'll just go ahead and round if you need to, but there it is. All right, so for the next question, we want the probability of a cat given that no dog. So this is very similar. We're just using the other row. So we are given that there is no dog. The total will be 0.61. How many of those people have a cat is 0.18. So we divide 0.18 by 0.61 and we get 0.30. And then our last question is what's the probability of a dog given no cat? So we have to start with the no cat. So this time we're looking vertically at this column. And how many of them have a dog out of that total? So 0.24 out of 0.67, and that answer is 0.36. So if we're talking about percents, you could convert those into percents. And one more example. This table's a little bit bigger, and the data is given to me in a frequency table over here. So first of all, we have to figure that out. So maybe we want to organize it into a table of values instead of a frequency table. So let's go A, B, C, and late, not late. So how many are there? Count them up. 4, 3, 4, and that's 10, 7, 12. So now I have the numbers just a little bit easier to work with. So we can add that up to the total of 40, which they also said that in the writing. And then we can fill in our frequency table. So one more time, if you'd like to, you can pause the video, divide each of these numbers by 40 and fill them in, and then add up your columns. This is a lot of calculator work. Definitely going to have a calculator when you do this. All right, so dividing by 40, 0.1, 0.25, which adds up to 0.35. For route B, we have 0.075, 0.175, which adds up to 0.25. And for route C, we have 0.1, 0.3, which adds up to 0.4. Adding vertically, we have 0.275 and 0.725, which adds up to 1. And we can also look up here, 40 plus 25 plus 35 is 100. So our table is accurate, so you always kind of want to check that one to make sure you got it set up right. And let's answer a few probability questions on this. So let me just check. I think they're on the next page. Oh, no, they're not. But we're going to ask them anyway. Okay, so what's the probability that you're not late given that you're on route A? So you can kind of tell here that most of the time you're going to not be late, but some of them are more late than others. Anyway, given that you're on route A means you're looking at this row. So you look at the second item, total across there is 0.35, so that's the bottom. And what's the probability that you're not late on that one? 0.25 divided by 0.35, which is 0.71. So 71% of the time you're not late. That's not too bad. Let's ask another question here. What's the probability that you're not late given route B? Because we don't want to be late. So given route B, 0.075 divided by 0.25, that one is 0.7. So a little bit more late, just a tiny bit more of the time. And then the last one, let's go ahead and see what's the probability of not late given that you're on route C. If you're on route C, we have 0.4, and if you're not late, that's 0.3 out of 0.4, which is 0.75. So 75% of the time. So which route is the best? And that's what it's asking up here. So the best route would be route C. Is on time more of the time because they're not late. Less, most of the time. You could also, if you're late, what's the probability that you were on route A? So that would be A given not late or late. So there's lots of different questions you could ask, but that is the end of 7.4. So this lesson is not super long, but there's a lot of computation. So have those calculators ready.